Oh, you guys are too kind. So today we're going to talk about implementing zero trust and what that means. And we're going to tailor towards Jenkins, but this can apply beyond Jenkins. So you'll see when we start diving in the tools that we're talking about, and it's not that hard to extrapolate it to GitHub Actions, to GitLab, to other tools. So what we're going to cover today is a really, really basic, what is zero trust? I have another talk and another track that goes into details on the gov track side, diving into what zero trust really is. But this is focused on the pipeline. So we're going to talk over some of the tools that you should use. The list of tools I'm going to give you is nowhere close to the tools that are out there. It's the ones I've used. I've been on a project over at Los Alamos National Labs implementing a secure pipeline for zero trust. So these are some of the tools that we use. So they are proven to work. We're going to talk briefly about what a developer's role in all this is. Everybody says shift left. So we don't want everybody on the production, SRE, release management side to do all the work. We want to make the developers do more work and go crazier. So that's our world. So we're going to touch upon the developer's role real quick, what they have to do on their side to make this all work. And then as part of the developer's role, we're going to talk about what happens in the pipeline for a PR or a merge request on that front. And then we'll kind of take a look at what a full pipeline is. So like I got introduced, I am Steve Taylor. I am the CTO of DeployHub. And I am one of the co-founders of another company I had called Open Make Software. I am on the TOC for the CD Foundation, and for the Ortelius project, which is where our green alien comes from, I'm the lead on that project. So Ortelius is one of the projects under the CD Foundation. So if you're looking for us, ortelius.io, you'll be able to find us. All right, like I said, we're going to jump in and I'm going to give you the long description of zero trust. Zero trust, we got to look at, we know that breaches happen when we talk about security. How are we going to make that better? So what we want to do in the zero trust world is we want to continuously validate who our users are. So do we have somebody sneaking in that shouldn't be there? We want to know where we're running, so what devices are out there, even if they're cloud or virtual devices, if they're an EC2 instance or a Kubernetes cluster, we want to keep track of that. And then finally, we want to know what applications are running where. So we want to make sure that we know who's using it, where it is, and what's out there. And from there, we can always verify what's happening at that level. So we don't want to go through and just say, okay, Mr. Developer, I'll give you root access to your EC2 instance because I like you. That's not a secure way to go about the world. You can give them access to that resource, but they have to make them jump through a few hoops. Assuming a role permission, audit tracing, extra level of security checks to get there. Maybe a jump server to get out to the production world, so you can track and audit everything that's happening. So, like I said, we're going to be doing, when you think about in the context of the CI/CD pipeline, never trust, always verify. And you'll see here shortly where that comes into play. Some of the tools you should use, these are ones I've used in the last year or two. Oh, And for those of you taking pictures, I don't know if these slides are going to be published, but I was hoping that they are. And these are all hyperlinks for you. So if you can get to the PDF, they'll have, in the PDF, it'll have the hyperlinks to get to these tools and websites. So just to try to make your life a little bit easier. So Megalinter is one of the tools I like. It's a linter formatter for over 100 type of languages. There's another one out there called Superlinter. I prefer Megalinter over this one. It's just a little more flexible. The other one is cosign. So signing, you're going to see we do a lot of signing. That's one of the things when you get into zero trust is you sign everything and you re-sign everything. And then you do verifications to make sure it wasn't tampered with. So we'll talk about cosign. Cosign's out of SigStore, and I can't remember if SigStore's in the OpenSSF or if they're in the CNCF. But is it OpenSSF? Okay, cool. Cosign's a very nice tool. I like it a lot for the signing. Another project is in Toto, and that really isn't like a command line program. I used it more like in a Python library that I could bring in and do some manipulation on the file side to create immutable records. And again, that uses key signing at that level. Now, when we get down into the pipeline, Trivy, Sift, those two are SBOM generation tools. The difference between Trivy and Sift is Sift just looks at generating SBOMs. It doesn't do any vulnerability scanning. You have to add on the corresponding gripe to do the vulnerability scanning of the SBOM. Trivy kind of has it all built in one, so you can do a single call where you have the SBOM generation vulnerability done all in one go, or you could do it in 2 steps. Generate the SBOM, and then take the SBOM and do the verification for vulnerabilities at that level. And then finally, Ortelius, it's going to be your dashboard to view all this. Anybody ever look at a SBOM? Okay. Anybody ever look at a SPDX SBOM? Isn't that messy? I mean, I could deal with reading Cyclone DX, but the SPDX ones, just you can't follow it. So my preference just for readability is I tend to gravitate towards Cyclone. It's just a lot easier to deal with. Also, like with what we do in Ortelius is we'll take a Cyclone DX SBOM and we'll store it into Arango as an immutable JSON object. So we version that at that level. So what that does is because Arango DB is a document store-ish hybrid, you can actually run queries against your SBOMs then very easily. So that's one of the things, like if you try to put SPDX in an Arango database, it's just, you can't do any queries. It's just too confused. All right, developers. What do we want a developer to do? Anybody? Give you a couple hints here. All right, so developers, we want them to lint their code beforehand. And not only for securities, like the leaks, did they all of a sudden, I mean, I just did this the other day. I'm like debugging my program away, I got Visual Studio up. I go into my Visual Studio config for my project, and I go throw my environment variable to say, this is my token. And I throw my token in there so I can debug my program. Well, I forgot to set up my git ignore for that project because the program was running fine. So now all of a sudden I do my commit, tokens up in GitHub by accident. I didn't mean to do it. So the Megalinter, running it locally, is something that you should get the developers to do. That'd be one thing I would ask the developers when you say push left, is to get them to lint their code. The other thing that it does is it really teaches you how to program better. You'd be surprised on, you get into a Python program and you kind of have Pydantic sort of implemented. You're starting down that path, but you're missing, casting variables and stuff like that. It really does help you become better programmers. I even throw Megalinter on documentation libraries. Because it has that 100+ world of linters, it'll go through and lint your markdown and say, oh, you have number bullet 1 to 5, and it'll catch that it's missing 3. So even on documentation libraries, I throw it out there. Some other handy tools on the developer side is the pre-commit hooks, trailing spaces, end of line. If you look up pre-commit hooks for Git, there's a little library that you install. Megalinter runs, it's a node program that you download, so npx install Megalinter. You do need Docker because it is an 8 gig Docker file, because it has all the linters in it. So just be aware. Yeah, it's a fun one to download. It's one of those you go to lunch and hopefully it's downloaded. All right, so this is all about Jenkins. So adding these tools is very simple. So like I said, Megalinter is going to run as a Docker image. So we're just going to tell Jenkins, hey, when you get to this step, run Megalinter for me and it'll return the results. There's some options to persist output as JSON, tables, just pure log files. It also has the capability of doing comments on your PRs. So when you go in as a developer, you do your PR, you do your commit, you get your pull request all set up. Jenkins kicks off on that branch. What will happen is if you give it the right tokens, it'll go back and comment and say, look, you did a pretty good job, but we found these 5 errors that we want you to fix before we allow you to merge cleanly. So set that up. Like I said, it's easy to do. You don't have to do it on every single developer's local commit. So if they have their own fork of the repo, you don't have to have them every time they do a push run Megalinter, but definitely run it on your PR. Because when it comes to the next step, when we do the merge request, we're going to run it one more time with a bunch of other stuff. All right, what else are we going to run? So like I said, we're going to go through on the Megalinter side, check for your leak secrets, formatting, best practices, and again, strongly recommend don't allow the merge to happen unless it's clean, because this is where you're going to catch a lot of the errors early at that level. All right, I don't know if you guys can see this because it is busy. All right, remember at the beginning, zero trust. What were we going to do? Anybody? Anybody? Yep. So look how many verify steps are in there. So I can't even read it because it's on my small screen here. So in our pipeline, the first thing we're going to do is we're going to check out our code. We're going to do our clone. Then we're going to run Megalinter. So whether it's coming from our merge request or direct push, either way, we want to do these steps. We're going to clone our repo. We're going to run Megalinter. If the merge request or the PR linting didn't catch it, we're going to catch it again, because there could have been something in the merge when we merged a couple different branches together. We need to verify again. From there, we are going to actually build the artifact. Now, I just made this very generic, whether it's a Docker build, or we're going to build a node, we're going to do some Python packaging, doesn't really matter. We're going to do the build part of it. And after that, we're going to run Trivy. So that's going to give us our SBOM. So our SBOM could be a SBOM of the repo, or it could be another SBOM of like your Docker image. So one of the things you're going to see here is we're going to get multiple SBOMs kicked out of this process, because they happen at different levels. So the repo level SBOM, let's say for a Python program, is going to go through our requirements.txt, give us our package dependencies, and kind of find the transitive ones from there and give us that SBOM. Now, if we bake that into a Docker image, we get a second SBOM when we run against the Docker image because we have the Python itself is going to come out at a lower layer. So as you go through this, you're going to get the multiple SBOMs that you have to aggregate together and keep track of. After you create your SBOM, you use cosign to go ahead and sign that file. And then from there, what I usually will do is go and turn around and verify it right away. So that's why you see this sign verify back to back. I normally want to make sure that the key wasn't broken. The public key is all of a sudden missing from the website of my well-known location. So what I want to do is go through and do my sign verify. After we do that, we're actually going to take that SBOM and look for the vulnerabilities based on that SBOM. Now, if you have a Docker image, we got 3 minutes. All right. Really? All right. So what we got is we're going to go through and kick out the multiple SBOMs and the multiple artifacts. So at the end of the day, we're going to, in this whole process, we'll have an SBOM file, an SBOM JSON, a signature file for that. We're going to have the vulnerability JSON, the signature file for the vulnerabilities. We're going to have our artifact signature, and that. So we have about 6 to 10 different artifacts that are going to package together into our release. Now, when we go to production and do this deployment, we could pull out our artifact, verify the signature against the public key. We can go take our SBOM that's there, pull that out, verify it against the public key. If we need to generate a new vulnerability check, we can use that SBOM that was there. So setting this up, simple cosign command. It has a bunch of different options for where you get the key from, but really simple to add in there. I would just play with it at the command line. So nothing fancy at that level. You can have it self-sign, which will go out to the SIG store, basically blockchain, and keep it there. I'm going to skip across a couple of these. Oh, went too far. All right, SIFT, Trivy. Stop moving. SIFT and Trivy, SBOMs, simple command line. You give it your repo, or you give it your image, and you have it kick out the JSON file for you. So this is not really complicated stuff to start securing your pipelines. And at the end of the day, what you're going to have is all this information will get pushed over to Ortelius, which is another command line that will aggregate all this together for you. So here you can see that we have different versions of Alpine, because we have different levels of containers that were used, base images. And we can see that we also have some vulnerabilities showing up, where they're coming from. So all of that is going to be aggregated together, so you don't have to read a crazy Cyclone DX or SPDX file at that level. Like I said, Ortelius.io, and I'm going to push it. We're going to take one question. Anybody have a question? I know this is quick. Like I said, way in the back. So Black Duck would be one of the, so the question was, how does Black Duck come into the play on this? So I'm trying to remember which one it is. So Black Duck will give us the list of vulnerabilities that are out there. So they have their tool to take an SBOM and give us the list of vulnerabilities. Depending on if you're having the open source version or if you have the commercial version, you're going to get the same results basically. Now what you want to do, like with Black Duck, is pull that information out, generate your reports, sign them, and associate them to your artifacts. So everything is, because what you want to do is when you go to production, you want to verify everything that you did and found using Black Duck as well. Any others? Yep. Guac and Artilius, there's not a direct relationship. They have a different view on what to do with SBOMs. So Guac will kind of takes an SBOM and looks at the packages and then looks for other SBOMs based on those packages. So it kind of does like this recursive SBOM finding. What Artilius does is it will take the high-level SBOM and go out and look like for your OpenSSF score based on that. If you want more details, then you'd have to do the deeper dive. But we're going to aggregate and look at the highest level, the vulnerability stance, your risk stance at that level. Does that make sense?